In the last video, remember we discussed about pressure at a point inside a liquid. But during that process, we assume that there is vacuum on top of the surface of the fluid. Now I'll tell you exactly why I made that assumption. Let's cut this vacuum out. And suppose that there is air now on top of it. Now this is air. And on top of it there is air everywhere. Why I made that assumption was because now you exactly know that if I extend this cylinder and if I'm interested in finding out the pressure at this point, and there will be pressure at this point because now the air molecules have come on top of it, and the same theory would apply. Instead of the water molecules, now there will be air molecules which are going to be little less heavier, but they have mass nevertheless. So there will be air molecules on top of it, and it will extend till the top of the atmospheric layer, right? So the weight due to all these molecules is going to get exerted, and now we'll have force and we have the area, and this force per unit area due to these air molecules is going to lead to what we call as atmospheric pressure. So this term here P naught is atmospheric pressure. So I think you get the idea. The pressure here now is going to be due to both the molecules of the air, the weight of those, plus the molecules of the liquid as well. So in that case, if we would have assumed that there is air here, which is the present case, then the pressure at this point P will be equal to pressure at S plus rho g h. And the pressure at S is actually equal to atmospheric pressure. So P naught plus rho gh is going to be the new pressure at point P if we were to assume that there is air also on top of this beaker. Now that we have defined why there is something called as atmospheric pressure into the picture, let's see how much is its value. So the atmospheric pressure at sea level, if you go to sea level, then the atmospheric pressure value is 101,325 Pascal, right? So this is around 1,01,325 newtons per meter squared. And sometimes, actually most of the times, this value is approximated to 10 raised to the power 5 newtons per meter squared. Because if you think about it, in front of 1 lakh, 1325 can be ignored. Okay, so in some cases we also assume the value, and in most of the cases it will be given to you, but we generally take it as 10 raised to power 5 newtons per meter squared. Furthermore, there are two general terms that you should be aware of when dealing with pressure, and they are very common, so let's discuss them. First is called as absolute pressure, and the second one is called as gauge pressure. What do you mean by absolute pressure? Absolute pressure is the net pressure at any point inside the liquid. So as we saw previously, if there is a point P which is h depth below the surface, and at this point Q, the pressure is P naught. So the pressure at P, which is total pressure, will be equal to P naught plus rho gh, and this is nothing but our absolute pressure, because this is the net pressure at the point P. And the gauge pressure is the excess pressure over the atmospheric pressure. So if you want to know what is gauge pressure at point P, gauge pressure at point P is just rho gh, because this is by this amount the pressure is in excess with atmospheric pressure. So rho gh is your gauge pressure, and P naught plus rho gh is your absolute pressure. By the way, this value 10 raised to the power 5 Pascal has a special name because it is used so frequently. It is called as 1 atm. So atm is nothing but 10 raised to the power 5 Newton per meter squared. One more question that I want to ask Can gauge pressure be negative? Can the gauge pressure have a negative value? Well, it can be. Think about it. If suppose at some place, and we'll see in what cases, if the pressure is only 0.9 atm, the absolute pressure is only 0.9 atm. In this case, if we want to write down the formula for gauge pressure, so gauge pressure, let me write it as GP. Gauge pressure is equal to absolute pressure minus atmospheric pressure, and which is 1 atm. So minus 1 atm, everything in atm. So this can be a general formula, and if we put this value in this formula, we'll get our gauge pressure as gauge pressure absolute pressure minus 1, which is minus 0.1 atm. And as you can see, this value can even be negative.